Yeah, so thanks everyone for joining. Today is going to be a presentation on Tableau and data scientists. And as most of you can probably empathize with the character I have on the screen here, the problems ahead of a data scientist are pretty complex. They've got complex challenges in terms of data, mastering technology, and also mastering the domains under which problems arise in their specific businesses. So what I'd like to do today is talk to you about how Tableau can be a tool in your tool belt to help you overcome those challenges quickly and effectively. So in preparation for this presentation, what I did was I watched a bunch of presentations by other data scientists that are on YouTube and Vimeo and stuff, and I found some pretty interesting information. This guy, DJ Patel, for example, he's the United States' first chief data scientist, and Obama appointed him to that position. It had never been a position before. And the presence of that position kind of speaks to the importance of data, now in government, but across all spectrums of both industry and government. The other speakers on this list, they all had pretty interesting things to say as well, and they all kind of had similar things to say. So what I was looking for when I was watching their presentations was just like advice on what data scientists should be aware of for the future and like what challenges they're facing right now, and that's kind of how I framed this presentation. And some of the things that every single one of them said were common, one of which was there's a diverse skill set that data scientists need. So they can't just rely on one tool or one competency to be proficient in their job. They need a mastery of several different skills. So some of these guys are really proficient in things like machine learning or SQL and some in visualization. And there are some people that have command over all those skills. From there, I tapped into this survey of data scientists that's done by this organization, O'Reilly, and they showed some of their survey results, and this is one visualization of those results. So again, data scientists don't use just one tool. You can see Tableau in there, but it's not the only thing in there. And this is just half of the tools that they use. My point here is that data scientists aren't just going to use one tool always, they're going to use a whole cluster of tools. DJ Patel even describes data scientists as one part analyst and one part hacker. So they have to have that proficiency in a bunch of different things in order to overcome the challenges that data presents to them. Despite all these different skills and tools that data scientists need, there are two attributes which were pretty common across all the descriptions of data scientists from those guys that I mentioned in our expert panel, and those were a good data scientist is motivated and resourceful. So a motivated person, like it's a great person to work with, it's the type of person that never says no or they never give up when a challenge is posed their way. And they're also very resourceful. And that's evident from the different skills that they have over here. Like they don't just have, they're not just a one-trick pony. They can use a bunch of different skills in their tool belt to overcome problems. So these two things have helped categorize data scientists from places like the Wall Street Journal as corporate superheroes. So they're turning previously conceived challenges from businesses into strengths or opportunities. And you think about that with like Amazon or Netflix, like the algorithms that data scientists are preparing and delivering to customers are helping those businesses retain and attract customers. So I started thinking, like, what's a superhero that's also motivated and he's also very resourceful and also mortal, because I wanted to draw an analogy between data scientists and a superhero, and I settled on Batman. So Batman, again, he's just a mortal guy, but he's got steadfast resolve. Whenever a problem's thrown his way, he sees it through resolution. He's called upon for the toughest tasks. You think about in your organization, if you're a data scientist, generally you're called upon to overcome a problem that conventional analysts just couldn't. And Batman relies upon a variety of tools. So he's got his Batbelt, he's got a bunch of different things on there, and then he's got a bunch of different vehicles, and his main vehicle is the Batmobile, which is a pretty versatile tool to have in your toolbox. And that's a good segue into my next point up here on dynamic range. So if you think about all these tools that Batman has, it's impossible for him to bring every single vehicle with him and every single tool. So in order to get his job done and do it in an efficient way, he needs a tool with the largest dynamic range. And that's something that DJ Patel goes into detail on several of his presentations. He says, there's so many tools out there, you should find one tool to master that has a broad dynamic range. And he draws up an analogy to an SUV. He says, when I was first looking at getting a car, I thought about getting, maybe like a motorcycle or, like a sports car, but they don't have a lot of dynamic range. Like, they can't go off-road. Maybe the horsepower is not as strong. Like, I need a car that can do a lot of different things so that I can just have one. So with that in mind, what I'd like to talk about is how Tableau can help you cover a lot of range, and it will continue to cover a lot of range because we have this research and development commitment from our executive team that's going to continue to enhance the product in the future to make it even better than it is today. And to validate that point, Tableau's got a 31% ratio of R&D to revenue. So that means that 31 cents of every dollar that we take in goes back into making the product better. And other tools, that ratio is something like 12 to 14%. Okay. So on this story point, what I'm going to do is just walk through some of the challenges that data scientists face. And I boiled this list down from the presentations that I saw and also from the survey on data scientists. And with each challenge, I'm going to have an appropriately pegged, I guess, villain from Batman to represent that challenge. And then at the end, I'll talk about how we overcome that challenge. So let's see our first challenge. And this is an obvious one: data access, data cleansing, data transformation. And the villain that I picked for this is the Joker. If you think about, that Batman scene in The Dark Knight where he's talking to the Joker says to him, he pulls actually a line from Jerry Maguire, he says, you complete me. So without Batman, the Joker wouldn't exist, and without the Joker, the Batman wouldn't exist. So what's that mean for data scientists? Like, so long as data challenges exist, the need for a data scientist will exist. So I thought, again, the Joker would be an appropriate analogy there for that challenge. And one interesting thing that I drew from that survey is that about 25% of respondents spend about 3 hours a day on data access and cleansing and transformation. And DJ Patel says a few times, hey, that part of the job, that's not the fun stuff. The fun stuff is throwing hypotheses and testing stuff against the data. So we want to make this part as quick as possible by using Tableau and some of the strengths of Tableau. All right, so let's jump to the second one, and that's statistics. So statistics have the perception of being complex. Sometimes they have multiple steps within them. They're not always evident on the surface what those statistical values are, what they mean. So I thought in that sense the Riddler would be an appropriate character to represent statistics. So in that section I'll show you how Tableau can help you overcome some of the challenges you might be seeing with statistics with simple point-and-click type of stuff. Oh, didn't need to do that. Let's jump to number 3. And number 3 is going deep with R. So just like Batman sometimes needs to go below the surface, down into the water to get the penguin, sometimes we'll need to go deeper than Tableau can support with certain functions by going into the world of R. And R is a rich community of people contributing these intelligent functions and libraries to. So if through Tableau we can dive down into R and bring it back into Tableau, we can capitalize on the best of both worlds. And then the next challenge is integration with other applications. So sometimes you need a multi-phased approach to analytics. So sometimes maybe you'll build some models in SAS, and then you want to visualize that stuff in Tableau. So I'll mention how we can do that quickly in Tableau. And then lastly, visualization and communication. So if anyone remembers the Scarecrow from the first of the Dark Knight series, he's got this like fear spray stuff that he sprays into people's faces and they can't see. It kind of incapacitates them, and they also can't communicate. So if you do all this work to overcome these first 4 challenges, but you can't visualize or communicate your information clearly, you're kind of doing yourself an injustice. So this is an important challenge to overcome for the data scientist. So again, with all of these, I'm going to speak to what these challenges are and then how Tableau overcomes them. All right, so first, data. And again, these are just little snapshots from that survey that I sampled earlier. Things like, 31% of respondents spend 1 to 3 hours a day on data cleaning. Like, that's too much. And again, DJ Patel says that's like the laborious part of our job. We don't really like that too much. The fun stuff for us is exploring that data and finding patterns in that data. So in this section, I'll cover how to address bad data, how to overcome no access to data, joins and blends, and how to make that simpler in Tableau. and how to avoid having to be proficient in proprietary languages. So with the advent of new technologies, there are new languages that people need to write in order to access that information. So how's Tableau bridging that gap and making it easier for people to tap into those sources of information without having to learn something like Spark SQL, for example? All right. So let's tackle bad data first. So this was an interesting story from Progressive Insurance. They did a presentation at our Tableau conference, and what they talked about was how they started tracking people's trips to help them, or to help gauge whether they are a safe driver or a bad driver, and then based on that score, they would give them a discount if they were a good driver. So as part of that, they gave them a little tracker to put in their car, and it started tracking their trips. It tracked their GPS locations. So before their data scientists started preparing algorithms with that data, what they did was they visualized that data to see if it made sense or not. So if you look at this map, would you say that there are points on this map that don't make sense from a driving perspective? And I would say absolutely. Like if I were driving from Wilmington, Delaware, where I live, to Atlantic City, I wouldn't want to do a jump off 300 miles out into the ocean. That wouldn't make sense. So what that tells us is there's some bad data there. And that was the comment that Brian Durkin made from Progressive Insurance, is sometimes messy data is more interesting than clean data. So this might have told them something about their algorithms to even collect the GPS data. And what it told them was sometimes around big cities, the signals get interfered with, and they spit out a signal that doesn't make any sense. So what they did was back up their process, go back to the part where they collect that GPS signal, and substitute in a value that made more sense than a value 300 miles out the city. Okay? So sometimes just visualizing the data before you start cleaning it up will help a lot. And that makes sense a lot, you know, with geographic information, or just with scatter plots or box plots. You can see outliers very clearly. And those are all things that are made pretty simple in Tableau to do. Okay. Now what about just connecting two data sources? So I mentioned the aggressive investment Tableau has into making our product better. One of the things that comes out of that R&D investment is new connections to newer data sources, one of which is Spark SQL. So in the data science survey that I read through, they said that Spark SQL was really jumping up as a tool that data scientists used between 2014 and 2015. So in 2014, it was only 5% of users and or respondents, and in 2015 it was 17%. So that's a 340% relative jump. That's pretty important. And Tableau caught wind of that and saw that people wanted a connection to Spark SQL because it's like 100 times faster than MapReduce. So we built that connector into the product, and now they can just connect directly to that. And that's just one of many direct connections that we have built into the product, and we will continue to build into the product as we go forward. Now, how about some of those things that David mentioned, like KPIs? So data scientists have a strong reputation for being proficient in some of these programming languages like C, C++, Java, and Python. The one thing that we introduced in Tableau 8.1 was the Tableau Software Development Kit. And what that allowed people to do is continue to leverage the skills that they're really strong at, or strong in, like Python, for example, where you can do all kinds of crazy predictive analytics, and then distill that information down into a Tableau data extract so the Tableau can use that and visualize and continue to iterate analytics on top of that data. Another benefit of having this approach is that you can tap into uncommon data sources. So I showed in the previous example all these different connectors that Tableau has. Well, we realized that that's not an exhaustive list. So if you can connect to those uncommon data sources with any of these languages, you can then boil them down to a Tableau data extract and then use Tableau on top of that Tableau data extract to do down the road work. So that's something that's relatively new that data scientists who haven't looked at Tableau in a while may not be aware of, but it's a really big part of our product, and it's continuing to blossom. And I think Bora is going to speak to more of what we're doing in the future to enrich the SDK and integration with other APIs. Beyond this, one point worth mentioning is that like any kind of Z code typically isn't supported by any vendor, and it's not with Tableau, but the community that supports anyone that works with Tableau is so strong that if you just pose a question about some of these APIs that you're preparing that are using the Tableau SDK, you'll generally get a response within like 3 or 4 hours. So as an example of that, I think I still have it up. I looked at like, well, hey, within these communities, what are people asking, and then how quickly are people responding to them? So here we can see on like September 28th at 8 a.m., someone asked a question, and then like 4 hours later, someone had a response for that person. So it's pretty comforting if you're walking into a new foray of programming that there is a community out there that's willing to help you. I thought I would just mention that to wrap up that topic on APIs. Now, what if you're a data broker? So, like, what if you don't make analyses in a silo? What if there are other people in your group you need to share information with? What can you do, or what can Tableau bring to the table to help you with that? Well, first of all, let's just tackle masking a data source. What I mean by this is, let's say that Batman gets this set of data that's in, I don't know, like DB2 or something, and it's got all these cryptic abbreviations of these fields over here. They don't make sense. What we can do in Tableau is update the metadata, so not necessarily the back-end data, but update the metadata that explains that data so that it makes sense for everyone on our team. Beyond that, we can create calculations, define them once, and make sure that everyone on our team is working from that same calculation. So I would ask you, like, if you replicate data to each individual on your team, how frequently do they come back to a subsequent meeting with a different variation of a calculation that you all should have? You know, usually that's pretty frequent. So with a control mechanism like this in Tableau, we can create that lens of the data one time, or you can iterate on it multiple times. You can be confident that everyone's working from that same lens of the data. When I say lens of the data, I mean like behind the scenes here you can see just the raw data itself, but when you put that lens in front of it, it provides more context to those people. So maybe like a villain, for example, someone spelled Joker, J-O-K-E, and then subsequent time, J-O-K-E-R. You can group them together. You can do all these different things over here, put them in this Tableau data source, this little proxy or this little lens, and then distribute it only to the people that are supposed to see it, again, so that everybody works in the same set of information. Okay? So that's the value to the data broker or anyone that's sharing data throughout your organization. All right? Now, what if we pivot over to things like joins and unions? So how long do you think it would take for someone to write this code, to test this code, and then finally to execute this code? Probably 2 or 3 minutes. Like in my previous career, I used to write code as a developer, and things like this, yeah, it would probably take me 2 or 3 minutes, and I was pretty proficient in SQL. Well, in Tableau, we can help the end user avoid having to write this with a more visual interface. So in this, what we're going to do is just take tables, drag them in, and then select the fields we want to work with and present them visually so that behind the scenes we'll create this stuff, but in the interface we don't see any of this complex stuff. We can just create this behind the scenes. So let's walk through that iteration now. So here, like, I'm dragging in tables, and visually it's showing me what kind of joins those are. I can alter them, and then I can select which fields I'm going to work with, and I use the show me to present this information visually. And this is just going to play on loop one more time. So we bring in those tables, we update the types of joins that we need, and then we select the fields that we want, use the show me, and we present this information again visually. So behind the scenes, this is what's generated, but we're working like 20 times faster by doing that visually in Tableau compared to churning out this code. Now, another benefit of doing it in Tableau is that Tableau does write this behind the scenes, so if you need to surface this code in your programming at some point, you can just expose the logs in Tableau and copy and paste this into your program. So those are 2 benefits of avoiding having to write code by using Tableau. All right. So now, what if you have information in multiple systems and you don't have the time, you don't have the months to do a full-blown ETL project? Well, you can sample that data and blend it into one common data source in Tableau. So here's an example where maybe Batman gets information on his villain masters, or the villain master, the profile of the villains in SQL Server, and then all the villain's crime history is in something more robust for storing massive amounts of data like Cloudera. Cloudera's implementation of Hadoop. So what can we do here? Well, we can use Tableau to blend these data sources together so that we can link this information and glean some insight. Now, what I'm not saying here is that Tableau is going to be able to handle billions of records from each data source, but what you can do in Tableau is cap it at some point and say, hey, maybe I just want to see the top 1,000,000 records for this billing. And this gives you an idea of what's in those data sources. So if you do need to launch a big ETL project down the road, you can rely on the insight that you glean from a Tableau blend. And this process is really simple. It's just like connecting to these different data sources, and then if there's a common field between these two, Tableau suggests that to you as the linking mechanism. And if those fields aren't exactly the same, like if this in this villain summary is VN and villain history, maybe it's the whole word villain, you can just define that field as a linking mechanism a different way. But ultimately, you can bring together data from multiple systems into one view to do analysis on it. All right. And how about statistics? So again, my perspective on statistics, I think back to when I took it in college in business statistics, and sometimes there were these really complex statistical models that we had to create. We had to do them on paper. And then after we did them on paper, we were introduced to statistics on a computer, and they're like 100 times faster. So I said, why would anyone want to do this the long way, the cryptic way, when we could do statistics very quickly just using a computer application? So in Tableau, we can execute those really quick statistics a lot of times just with a right click and a left click. So let's walk through a scenario here where maybe Batman has Alfred make a time machine for him, and he says, hey, let's go back in time, and we'll concentrate on the years where there's the most crime, and we'll attack those years and see if we can make an impact there. All right? So here's that example. Like, here's crime over time. Batman's first year in business, as far as Michael Keaton was concerned, was 1989, and you can see there was a slight rise in aggravated assaults, and then it really drops off when Batman starts upping the ante, I guess. So let's say we wanted to just describe this data set with some basic statistics. How would we do that? We can just right-click anywhere and say, show me the summary, and Tableau will show you descriptive statistics on all this data here. So we can see there's the median, 41, actually I think this is 41 million aggravated assaults for this whole data set. Well, what if I wanted to see that visually alongside my data? What I can do is come up here to Analytics and just drag in my median. So I'm going to put that on my aggravated assaults. And now I can see very clearly, like, these are the years that are above that median. All right. So if I wanted to just focus on those years, I could select them manually or programmatically. I could do either and create a set based on those. So in this case, I want to say these are high crime years. With my time machine, I want to target these years and really try to bring down aggravated assaults. And then what that does is it materializes a set of data to that lens of my data that I talked about earlier, so I can reuse this anywhere in my analysis. Okay? So let's say I want to look at another attribute of my analysis here. I want to see if I go and tackle burglary, for example, what other crimes are likely to go down if I'm just looking at it from an associated perspective. So if I'm just visually looking at this stuff, it looks like larceny is pretty correlated linearly to burglary, all right? And right now I have that high crime years set on my filters. If I take that off, I see all the years there. But I can reuse that thing I just created, drop it back on filters, and thin out this data set and just focus on the stuff I want to focus on. But let's really dig into the relationships between burglary and some of these other types of crime. So if I right-click and say, show me a trend line, Tableau is going to plot out a trend line for each one of these relationships. All right? So I see, like, I thought larceny probably had the best or the closest relationship to burglary. It shows me the R-squared value is just 0.5. But if I come down to motor vehicle theft, I can see that the R-squared value is 0.73. So that's a stronger relationship. Now, if I want to dig into that model even more and see the underlying information, I can continue to do that. I just right-click and say, show me everything about that trend model there. And I get this more rich palette of information. Okay? So, in this example, we walked through real quickly, how we can use statistics in Tableau to glean insight from the data. With that said, though, and again, I mentioned this earlier, sometimes we need to go deeper than just what's on the surface in Tableau. In the art community, there are thousands of contributors to the art community, again, with unique ideas and brilliant functions that they baked in to their libraries. So what if we can use them directly in Tableau? Well, in Tableau, it's real simple to do. We just use a calculated field. So a calculated field, I'll show you one example of it. If I come back to our example over here, if I wanted to see any types of crime or any aggravated assaults, any years of aggravated assaults that were greater than 1 standard deviation from the mean, I can just create that with a calculated field, drop that on color, and I'll visually see, hey, what years are higher than 1 sigma plus mu there? And there I see it very clearly, all right? But if I were creating a calculated field that needs to pass something to R, I just wrap it in this thing called a script underscore real. And this tells R, hey, I'm passing you this logic. You got to return to me whatever I tell it to return to. In this case, my p-value, all right? So in this example, let's say that Alfred is procuring antidotes to the scarecrow's fear gas, all right? And every time he absolutely needs 12 ounces in that antidote. Well, he's been getting less than 12 ounces pretty routinely, so he wants to run a t-test to see if the underfilling of those vials is significant. So let's run through that test. So we've got 12 ounces over here. Here we can see a little box plot of where those things are. And again, here's 12 ounces. We've got a lot of observations underneath 12, but are they significant? So what we can do is just, again, thread in that script real and the R command, and Tableau or R will return to us that p-value. So I just took my p-value, I put it on my label over here, and we can see that the p-value is beneath 0.05. So it is significant that they are underfilling our vials of antidote, and we should have a conversation with Batman and our vendor to figure out why that's happening, or maybe we should go to a different vendor. My point there is we can integrate Tableau and R very easily. It's just a calculated field that gets passed back and forth. All right. Beyond what I've just showed, that's really just skimming the surface on statistics with Tableau and Tableau and R. There's a whole litany of different links out here. I can send this forward to you guys after this presentation if you want to look into it deeper. But there are a lot of great blogs and a lot of great articles explaining how to do all kinds of different statistics in Tableau. And then just pivoting a little bit into a different foray of R, what if it's not statistical in nature that you want to do some analysis on? What if it's something like sentiment analysis? So in this situation, let's say that the commissioner calls up Batman and he says, hey, listen, the public's turned against you. They don't like vigilante justice anymore. We want to shut you down. And Batman says, well, I'd like to say otherwise. I looked at my Twitter feed the other day and it was all positive. Let me use Tableau to layer on top of that Twitter data, and I'll see if truly the sentiment is positive from all these tweets. Now, it's impossible for Batman to comb through millions of different tweets himself, but if he uses the sentiment package that's available in R to do that for him, he can quickly see at a glance, hey, what's positive, what's negative, and on the whole, am I trending positive or negative? So what he does is he just goes out to Google and he searches Tableau Twitter analysis, and he gets something like this. And he can just rebrand this for himself. Right now, it's just for Tableau. Like if you were looking at this himself, he would say, well, yeah, I'm really popular in America. You can see that by the size of just the United States over there. And here are some of those tweets that correspond to America. And if I come over to the emotion dashboard, here's where the sentiment is diagnosed based on the tweet, based on the lexicon that's in that sentiment package. So we can see like these two guys up here really love, in this case, Tableau, and they tweet a lot. So it looks like there are a lot of tweets over the last few weeks. If I just select, I don't know, just this guy himself, what kind of quantity of tweets does he have? He's got over 30 tweets for Tableau in the past week or so, which is pretty nutty almost, pretty fanatical. But hey, we love people like that. And then he's retweeted often. And like, what's the sentiment of his tweets? It's largely positive. So Batman just rebrands this, brings it back to the commissioner, and the information is not as damning as the commissioner says, maybe they don't shut down Batman. You can continue to operate. Okay? And then just progressing through our series of story points up here, if you want to capitalize on other analyses, you can too. So if you do advanced statistical analysis in something like SAS or SPSS, and they can output stat files, we can read them in as easy as if they're just like an Excel file. And then we capitalize on the strengths of Tableau that these other applications don't have, like visualization and collaboration, stuff like that, just by reading them in as a stat file. So this is something that was included in Tableau in one of the newer releases. I think it was 9.0, but it's doable now, and it's pretty neat. Then progressing through, if we come to visualization now, I already talked about this a bit, but if you just look at data in its standalone state, nothing really pops off the screen at you, especially if you're looking at a data set of like 100,000 entries. But if you present it visually, you will see some patterns that elicit a certain response from your audience. And Tableau makes creating visualizations from your data very easy. And I'll skip through that. I was going to do a whole demo on that, but for the sake of time, I'll continue to just hit the really important points of these next few story points here. Continuing on visualization, if you need to tell your story to an audience, we need to help you communicate your story pretty well. So some of the data science presentations that I saw, they were laden with scientific terms that were too deep even for myself to understand. So if we can communicate the main part of our message by kind of shielding users from the scientific method of your analysis and just showing them what's important visually, then we're helping you in your endeavor to enact change within your organization. So what facilities exist within Tableau to help you do that? So I'll start at the top left and then work my way down. So first is the Show Me feature in Tableau, and this is huge. Like if you just select a few fields over on your left, Tableau will only show you the visualizations that are relevant for the data that you have selected. So here I have like a time series. Like I just have year and aggravated assault. So what would not make sense is to show them a field map, for example. There's no geographic data in play there. So what this does for you is it helps save you time from having to experiment with a bunch of different visualizations, and it also helps you tell a very clear message visually. So a bar chart would be an effective way to show that information. Further, if you have different components of your analysis that you want to weave together, you can just leverage a dashboard in Tableau. This whole palette right here is actually a dashboard. So you would put the most meaningful information up top here, and then maybe some supporting detail down below, and allow people to interact with your dashboard. So you would say like, well, hey, what are we doing in the Northeast up here? And you select the Northeast, and all the detail updates down below. That can create a two-way interaction, a two-way dialogue between your users and the data. All right. And then lastly, we have this thing called stories, aptly named stories. And these are all story points up here. So if you have a story that won't be told completely with just one dashboard, maybe it needs to be told with like 20 different dashboards or 3 different dashboards, you can sequence a bunch of different chapters of your story from left to right, and it helps you do a few things. It helps you stay organized, it helps you know what's coming next in your presentation, and it helps your audience be aware of what's coming before and after each component in your story. One thing to be aware of when you're telling a story, especially a story with multiple points, is that you need to capitalize on people's attention span. So if you have a really long story to tell, chop it up into individual stories and make sure that you tell your most important point of that story right up front, and you recap that at the very end, because people's attention spans tend to drop off in the middle of your presentation or in the middle of your story. So if you have this really long story and you just told one whole story, everything in the middle would kind of be forgotten, but you stand a better chance of having your message be listened to if you break it up into individual components. And then I'll skim through these. I didn't realize how much time I was taking up, but if you present your audience with the opportunity to interact with the dashboard, it will let them ask what-if questions, and they'll be more engaged in the analysis that you have. A Tableau server can help you securely communicate with only the people you want to communicate with, and it will help them share content and create ideas and iterate on the ideas that you are creating. And then this last point, I just wanted to summarize. I would ask you to all look through each one of these challenges and think about whether you have a command over them. And if you don't, please reach out to us or capitalize on some of the links Tableau has out there to help you get stronger in these areas. You can work quicker and more effectively in your endeavors as a data scientist. Now, with that said, I apologize for taking more time than I thought I would, but I will pass the ball now to Craig, and he can tell a story about how he uses Tableau in his daily job.